We are going to talk about set notation. And in our first question, they are asking me to write a set using a roster method. Roster method is just a fancy way of saying make a list of your elements. So they have given me a set. It's actually written in what's called set builder notation. Notice, first of all, the name of a set is a capital letter. And then with sets, we put them in brackets. So that's just showing you that it's a set. So the first thing that will appear is the variable. So in this case, they're using the variable z. And then they give you a description. So they're telling me that z is greater than or equal to 17, less than or equal to 39, and it is a multiple of 3. So when I'm asked to give the roster method, I'm going to just make a list. So starting with numbers that are greater than or equal to 17 and a multiple of 3, that first number would be 18. So I'm going to continue with my multiples of 3. We would have 21 plus another 3 would give me 24. And I'm going to keep going until I get a z value that is less than or equal to 39. So 27 plus 3 would give me 30. That's a multiple of 3. Plus another 3 would be 33. Then 36. And then 39. Now, do I include 39 or do I not? I have to look closely. If it has the bar, that means you do include it. So 39 would be part of that set. And then we close off with the bracket. So this would be the roster method for that particular set. In the next question, they're asking me to write the set with set builder notation. And they've got boxes for me to fill in and do that. So they've already started with the name of the set, which they told me is M. And this is the set of natural numbers that are less than 13. They do tell me to use the variable x. So notice they already have the bracket there, right here. So the first box, I put my variable. All right, then they have this bar. That just means such that. That means they're fixing to give you the description. So first we're going to say that it's a natural number. And so the way we write that with symbols, we've got our variable. We say x is an element of, and that's the symbol that means is an element of. It should be on your keypad with the program. And then your natural numbers we represent with a capital or scripted N, and again you'll see something like that on your keyboard as well. And then they've got a comma here, and so then the second thing is we have to say that it's less than 13. So x is less than 13. Not equal to, just strictly less than. And that is what your set builder notation would look like. All right, in this third question, they've given me two sets. They've given me set A. Notice it has letters of the word whiteboard. And then they've given me a universal set. That's kind of like, think of it as the universe. And notice that is the entire alphabet. So they are asking me to find what's called the complement of A. So when you see what looks like an apostrophe, that's not actually what it means in set notation. It means complement. And complement means what is missing or what is not in the set. What is not in the set. So what is missing, what's in your universal set that is not in the original set. And then you're just going to make a list. So I'm just going to start at the beginning. So A is in my set, B is in my set. I do not see C, so that would be in the complement. D is there, E is there. I do not see F, I do not see G. H is there, I is there. I do not see J, I do not see K. I do not see L, and ideally you don't want to continue it on another line, but I'm out of room, so I don't see L. I do not see M. I do not see N. O is there, but there's not a P, there's not a Q. There is an R. There is not an S. There is a T. There is not a U. There is not a V. There is a W. There's not a X, there's not a Y, and there's not a Z. And so, technically, let me come up here. You'd write it all out in one row. So C, F, G, J, K, L, M, N, P, Q, S, U, V, X, Y, and Z. Those are all in the complement of set A. All right, on the next one, we're being asked to determine what's called the cardinal number of a set. Cardinal number just simply refers to how many elements are in the set. How many elements are in the set. And so I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you'll notice that the notation for cardinal number, they write what appears to look like absolute value bars, but that is when you're talking about sets and set notation, that is the notation for cardinal number. So this translates into the cardinal number of set X is equal to, and then we just put our answer there of 10. All right, last thing we're going to talk about are equal sets. In order for sets to be equal, they have to have exactly the same elements. It does not matter the order of those elements, but they have to have exactly the same. So we're looking at two sets, P and Q. We're going to see if they have exactly the same elements. So starting out, I see the word horror. It is part of both sets. I see the word romance. It is part of both sets. I see the word sci-fi. It is part of both sets. I see the word action. It is part of both sets. And finally, I see the word comedy. So both sets have exactly the same elements. They're just in a different order. So down here, I would say yes, meaning yes, they are equal because they have exactly the same elements. They are just in a different order. And then on my last example, again, we're looking at set P and Q. We're being asked if they're equal. So notice P has specific instruments, a piano, a guitar, drums, flute, an oboe, and a violin. Whereas Q is described as just the set of anything that is a musical instrument. So it not only would include the 6 listed in P, but it might include others like a saxophone or a trombone. So Q is going to have a lot more things than P, and therefore, they're not going to have exactly the same elements, so they cannot be equal. So we know it's no, and in this case, we're going to say no because P has fewer elements than your set Q, so they cannot be equal.